Hello student, this side Abrar sir again, and I hope you are doing well. In the last topic we have talked about the laws of refraction, absolute refractive index and a relative refractive index. In this video we'll talk about the refraction by lenses. So let's start. So we'll talk about refraction by lenses. So we know that we have two kind of lens, that is convex and second is concave. So students, before making diagrams we must know the laws which we need to follow before making diagram. But before that we need to know all lenses are also made by some glass which having center of curvature, radius of curvature, the same terms as we followed in mirror. But here if I tell you the shape of convex mirror is like this is convex lens. So these are the converging lenses. In this the light converges a point and make real image. But in case of concave lens, or we call them as diverging lens, the lights get diverge and they make virtual and small image. So students, rules. Now we'll talk about the rules for image formation in lenses. So first rule is incident on the lens, incident ray on lens parallel to principal axis. Incident ray on the lens parallel to principal axis passes from focus on other side. What does it mean? It means any ray coming parallel to principal axis. This is the optical center. Any ray passing from optical center will not deviate, and the light coming from the edges of the lens will deviate maximum, while the light coming in the inner part of the lens deviate least. After refraction they meet point focus. So incident ray lens parallel to the principal axis passes from focus on the other side after refraction. any light coming from focus will travel parallel to principal axis after refraction. That is reciprocal. Reciprocal means say any ray coming this point will travel parallel to principal axis, will travel just the reverse of this. Any ray coming from focus after refraction will move parallel to the principal axis. And for the third point that I've told you, third is any ray passing from optical center of lens will not deviate or refract. That means say this is the optical center, this is the principal axis. Any ray, suppose that any ray is coming from this point, will travel straight, will not deviate. So these 3 points will help us to draw the ray diagram. Any ray passing from the optical center of the lens will not deviate or refract. So student, now we will form the image. We will start the image formation. Image formation or ray diagrams using convex lens first. So student, now we are going to draw the ray diagram. Now we are going to draw a ray diagram. So first case is object is at infinite distance from lens. So okay student, so object is at infinite distance. This is the half of the lens. Principal axis. Any distance is at infinite. Any object is at infinite distance. And the rays of light coming from parallel from a large infinite distance, and they all meet focus. So the light is coming from infinite distance. After refraction, they all meet at focus. So in this case, image will be at focus. Point sized, real and inverted. Real and inverted. Right, students? Now the object is kept at focus. The object, second case, is kept at focus. So for the focus, where will we obtain the image? Let's see. Here. So object is kept at focus. We kept the object at focus. So this is F1, F2, C1, C2. So putting the object at focus, let's see where will we get the image. So students, it is quite evident, quite clear. These two rays of light is parallel. So geometrically they will not meet, but this is the case of light, so we believe that the light will meet somewhere in infinity. So in this case, image will be at infinity. Image will be at infinity. If they will meet, they will form the real, inverted and highly magnified image. Highly magnified image. So student, we have seen that when the object was at infinity, the image was forming at focus, and when we put the object at focus, we are getting the image at infinity. When the object was at infinity, image was very small, diminished point size, while when the object is at focus, the image is very magnified, real and inverted in both the cases. Okay students, so now we will put the object beyond C. The object kept beyond C. So in this case, when the object is beyond C, the object is beyond C, F1, C1, F2, C2. So the image so student, the image will be formed somewhere between F and C, somewhere F and C. So image will be between F and C, real, inverted, smaller than smaller than object. So this is the observation when object is beyond C. When object is kept beyond C, the image is obtained between F and C. The image is obtained between F and C. Okay, so now we keep the object between F and C. So next case is when object is between F and C. Now we are taking object between F and C. So let's see where we will get the image. We are putting the object between F and C. This is F2, C2, C1. Now we are putting the object somewhere here between F and C. Let's see where we'll get the image. So students, you can see it is quite evident the image will be students, you can see if you place the object between F and C, between F and C, then you will get the image beyond C. You're getting the image beyond C. So image will be beyond C. Beyond C. Real, inverted, magnified. So student, when the object was between F and C, the image is forming at C, magnified. Here when the object was beyond C, the image will be between F and C and smaller than object. When the object was beyond C, the image was between F and C. Smaller than object. While we put the object between F and C, the image is beyond C. The image is beyond C. Magnified. Okay, students? Now, we will keep the object at C. When the object is kept at C, the object is at C. The student in this case this is F1, C1, sorry, F2, C2. So if we keep the object here, the same size image we will get here. So student, when object is at C, the image is also at C. Same sized image. So when the object is at C, the image is also at C. Same sized, real, inverted. So student, when object was at C, the image is also at C. Same sized, real, inverted. Now students, we will go for the last case of the lens for today, that object is placed between F and O. That is optical center, F and O. Let's see student how this image will be formed. Student, this is F1, C1, F2, C2. This is O, the optical center. So we are willing to place the object somewhere between F and O. So we place the object between F and O. Let's see students where the image will form. So student, light is going this way. Where will we get the image? So student, we will get image of this case somewhere behind the lens. So students, we will get a virtual image at this side. We will get the virtual image. Student, the image will be formed same side of object. Magnified image virtual and erect. When the object is between F and O, the image is forming same side, magnified, virtual and erect. So student, for today's class this is, and if you liked, understand, please subscribe, share and like, so and support me so that I'll make more informative video for you people. Thanks for watching.